Hello everyone, I'm Eamonn, and I'm going to talk about serverless. So, as Charity mentioned, with some skepticism, serverless is a big thing right now. So, and the actual space is kind of a little hard to define, and it's also a little confusing. So I'm going to actually step back a little in history first and talk about how we got to serverless and what we can learn from history in terms of understanding the current state of the world, and talk about what's good about serverless, and as Charity mentioned, talk about what's not so good about serverless. So I'm going to frame this through kind of my experience over the years. So before there was serverless, there were servers, I guess. But before there were servers, I've actually been in this game long enough that I can remember when we didn't use servers, when there was no internet-connected servers. I started programming, doing chip design software when we just worked on Unix workstations and shipped our software to chip designers who were also on their own Unix workstation. So no internet outside kind of the realm of academia. So then servers started to become a thing, mostly in the enterprise space, and it was mostly very specific to particular cases. There was like mainframes that were servers, there was particular like MS-DOS client software, there was very application-specific protocols. There were some efforts in that period to try to make it more general. There were things like Corba and DCOM and things like that, but they never really took off. I mean, within their realms they were successful, but they never really took off, and mostly because they required this kind of tight binding between both sides. But then along came the web, and the real kind of vision there was this idea of a generic client. So now instead of specific clients, we had this generic web browser, and the beautifully simple HTTP 1.0, which allowed this kind of loose coupling, just the right amount of coupling that allowed you to build systems that could just like explode onto the world. It was around this time too that I kind of shifted over from chip design software to the web world, and this was around the time of the dot-com boom. So back then we sure had servers. We had bare metal servers. We went to, we lugged them to a cage in a colo in a data center down in San Jose, and our little startup had our little cage, and there was like all these other startups with cages. So very, very physical, very much servers. But of course, it was actually, there were just Unix servers just like I'd used before on my workstation, same tools, SSH into the thing, installed stuff. So then .com collapse. Ooh, we didn't make millions. But I ended up in another company in HP at the time. And after a few years there, I ended up being tasked to kind of take some of our code that was like machine intelligence stuff and put it out onto the web. And by then things had changed, right? The big thing that had changed was the fact that now there's VMs, and Amazon was able to take advantage of that and offer infrastructure as a service as part of the public web. So this was great. I didn't have to go to my local IT and beg them to kind of provision some machines for me and connect them to the internet. I could just kind of hand over the credit card to Amazon, and it'd give me as many VMs as I wanted. But it was still servers, right? I was still using exactly the same tools I'd used on bare metal. I was still using exactly the same tools that I'd used when I was working on my Unix workstations. I was SSHing into things. I was installing WAR files. I was rebooting things. Though of course now DevOps was kind of in the air at this point. This was like the mid 2000s. And of course I was starting to automate all of this. But it was still very much a server world, a server-oriented world. And around this time, people started reacting to kind of just the complexity of this. It started, in some ways, it's a little bit similar to what serverless is like now. There was no consensus on how all this stuff should all come together, and people were building all these different solutions on top of HTTP. And then it had happened really, I mean, Roy Feldman came up with this idea of REST back in the early 2000s, but it really only started to take hold in the mid to late 2000s. And it really transformed how the industry kind of started structuring things. It really clarified a lot. And of course, it coincided at the time with the rise of the rich application interfaces, initially Flash and later kind of single web applications which are generally all backed by REST. Okay, and then the core thing about REST is that it was true to the original Tim Berners-Lee notion of loose coupling. So here's REST on the left with it. This is a diagram from a paper showing kind of essentially coupling. All the other competing solutions that were built on top of HTTP were very tightly coupled, and they all failed, but REST succeeded, basically. Okay, let's go on to serverless. The first thing is not really what people call serverless, but it is the first hint of serverless to come. So even back in the 2000s, companies like Flickr started providing APIs. And I remember like building apps on top of Flickr, and it was great, right? You could write client-only code that was built on top of their backend. So it was a kind of serverless. You didn't have to worry about the servers. Of course, very specific. You could only build imaging apps, right? But still, it was a hint of what was to come. The next thing was platform as a service. And now this was just like the infrastructure as a service had been enabled by the rise of VMs as a technology. The rise of containers as a technology allowed platform as a service. Certainly, Google App Engine was enabled by the internal container technology that Google had. And Heroku, actually, I don't know what they use internally, but I'm guessing they had some kind of container technology behind their stuff. So Heroku and Google App Engine were the two players in this field. Now, around this time, well, this is about 5 years ago, I actually moved to Google and just kind of randomly ended up in the Google App Engine team, mostly because they were in San Francisco, and who wants to work in Mountain View? So I ended up right in this space, and at that time, App Engine was already 5 years old, and basically, App Engine really was, I think, really the first serverless. I mean, the term wasn't used at the time, but it really had that attribute of allow you to say, okay, just take my code and run it. If you didn't care about scaling, it would take care of scaling, and it just charged you for your use. But there was a totally other kind of serverless, and this is another kind of serverless that people normally don't actually include in serverless, which is the backend as a service. And some of the players there was Parse, which I know there's people in the room know all about, and also Firebase. Was another example of backend as a service. And this was also had the characteristics of just take my code and run it, except in this case, instead of like PaaS, where it was take my backend code and run it, this was take my front-end code and run it like on top of SDKs that kind of make it appear almost like you're programming locally on the client device, but it's actually talking to some backend service. And then there's, of course, functions as a service, which Ryan kind of told us all about, so I won't go into details. So this is what most people actually think of as being serverless. This is the function service. It's got lots of great use cases, including kind of microservices. And then there's something that kind of brings it all together, which is the eventing. And again, Ryan kind of talked a bit about this, how you can drive functions from events. And this, I think, is where we're getting back to kind of the way REST kind of clarified and kind of made the kind of the Wild West of the 2000s tractable. I think that declarative eventing is something that is now going to make serverless tractable. So this is basically the idea that you can declare that a certain change in state in some service can cause something to happen elsewhere in some other service, which would be like on the other side of the world. And generally, that thing to happen is a function firing, but it could be more general. The nice thing about this is that all the cloud vendors are providing this. Azure has their event grid. There's the Amazon stuff we heard about. We in Google have something similar. Plus, there's a bunch of open source things like Riff and so forth, which you can install on-prem. And what's more interesting is that all of us are working together in the Cloud Native Computing Foundation to kind of make sure that all our events can be interoperable. So there's this kind of world in which we can essentially allow you to build applications on top of like multi-clouds, on top of kind of a hybrid on-premises cloud solution where you can have events arbitrarily kind of crossing boundaries. Okay, so I hope you all, if you weren't convinced already, serverless is awesome. And I agree the name is kind of bullshit, but there are servers, of course, but servers you don't have to worry about. But okay, let's get on to what's less good about serverless. Okay, debugging your code is harder. Really, the tooling is still immature. If you write a bug in your code, maybe you don't write bugs in your code, but I have bugs in my code. It can be hard to find them. And I would say there's actually no silver bullet to how to solve this thing, and it's really just kind of do all the standard things, except you've got less tooling to help you do it. You know, there's some parts of your code you can refactor out that kind of like doesn't depend on the platform you're building on, and just like do unit testing there. You know, do continuous integration, continuous deployment to non-prod stacks. The one thing actually is slightly easier here is that normally there's a kind of a certain skepticism about testing on staging, whether like testing and staging can give you confidence in testing and prod. It's a little easier in serverless because you can, it's a lot easier to create staging that looks exactly like prod. Now, if you're really scaled out in prod, of course, it's hard to get the same scale in staging, or you don't want to pay the cost of having the same scale on staging. But as long as you're not vastly scaled out, you can actually get staging pretty much like prod. So this actually is a little easier in serverless than elsewhere. And then, of course, you know, observability, and you will find some people in the room that will help you out there, of course. Okay, so that's, assume you've fixed all your bugs, your code is perfect logically, but now you've gone from running, if you're moving to serverless from say like single computer or single kind of client server thing, you're now running on this like planet-spanning distributed system. And you don't actually know where all your stuff is running, and you may not have control over it. So there's all kinds of bad things can happen there. So way back in the 90s, in Sun, some people came up with the 8 fallacies of distributed programming. And I think it's worth kind of looking at these again, because I think even though they were mostly talking about the kind of distributed computing kind of in relatively small scope, I think it applies to this kind of world-spanning stuff too. These are all things that if you come from like a single programming kind of programming a model, you might kind of be inclined, even though you kind of know in theory that these things are not true, it's very easy to fall into the trap for forgetting these. So we don't have time to go through all of these. I'll just go through the first 4, and particularly concentrating on the security one, the 4th one. So the network is not reliable, right? So for example, take backend as a service code, where you're writing client code that looks as if you're kind of writing into a local store, but you're actually writing to something that could be a continent away. So it could fail, right? So you need to make sure you're doing all the error handling there. Another kind of subtle thing is some of the declarative eventing code, depending on the platform you're using, it can look very much like UI event code. So in the UI event, right, you can have like on click, say some button that the user clicks, then execute this callback, which may be just a lambda right there. And you can inspect that and know for sure there's an exactly once relationship, that if that thing happens, then this other thing will happen exactly once. Now, in a declarative eventing system where you can declare, like, if this like database value changes over here, then this function, then the snippet of code should run. That snippet of code could be running on some kind of function FaaS environment somewhere else completely, and for sure it is not happening exactly once. In fact, there's a theorem that says it cannot happen exactly once. If you're unlucky, it'll happen like at most once, which is a pretty bad place to be, because that means, you know, who knows, you may get your event firing. If you're on a good system, you'll get at least once, which means that you can be sure your function will fire once, but maybe it'll fire twice or maybe more times. Hopefully that's rare, but you still have to write your code on the assumption that your function can fire multiple times in response to a single event. So you have to make sure it's like idempotent for the things you care about. So there's some examples, and there's lots of it. So basically, you can't be lulled into the false sense of security that it is just like writing kind of for a kind of a much more constrained single computer type environment. Latency is 0, of course. Latency is not 0, and a lot of these latencies can build up to things that are human noticeable. So you often need to redesign your UX to take care of that. And bandwidth is not infinite, right? So if you have like large assets, like videos that need to go to users, or if you have just data that needs to be transferred to places where the computer will operate on it, you need to be aware of that. So in some cases, you don't have any control over this, depending on your cloud provider. In other cases, you can control to some extent at least what continent you're on. In some cases, down to the kind of like region of the continent. And so if this matters, you need to take care of that. And then finally, security. So the good news is some things are easier, right? The whole infrastructure level security, you don't have to worry about that. Your cloud provider takes care of that. The bad news is, okay, you still have to take care of some stuff. There are still threat models you need to be protected against, and actually, you have a bigger attack surface where people can attack. So you need to be careful about that. So I'll finish up with this slide. Basically, these are just some examples. For example, the event that you're receiving into your function, maybe there's some way that an attacker can inject that event in. So you might assume that event is coming from your system, but you know, just like you do currently with data coming from a user, you should assume nothing, trust nothing about an event coming in. You know, sanitize, validate everything. Don't pass it through to a interpreter or to a SQL or whatever. The other thing is that an attacker can manipulate the sequencing. You might have some serverless thing set up where you have a sequence of operations that are passed in some chain, and that's the way you've built it, and you've assumed that. For example, you know, you might have say a authentication step in between something. But maybe the attacker will find a way of kind of rerouting an event around that and bypassing the authentication. Okay, so you should not assume that it's been authenticated without. You should not assume a particular order of execution of the steps. Speaking of authentication, you know, probably shouldn't roll your own authentication. All the cloud providers provide their own authentication system. You should use that. And then on a related note is authorization. So pretty much you're building stuff that are stateless. I mean, these systems basically kind of drive you towards stateless systems, which means your state is stored in something, like in a bucket, in a blob bucket, in a database system, which has to be exposed to your, in a sense, across the internet for you to access. So there are so many headlines of people exposing S3 buckets or Google Cloud Storage buckets. You know, don't do that, right? Make sure everything is locked down. And then finally, you know, Ryan mentioned building your Python thing from all these dependencies. You should audit those dependencies. You know, make sure there's nothing insecure in there. It's very easy to bring in an insecure dependency. So that's it. Serverless is great, but it's not magical. It can be a little hard to debug. It's an inherently planet-spanning distributed system that brings all kinds of new features that you need to be aware of, and attackers have new ways to attack you. Thank you. Well, I mean, it depends on your provider, right? So I'm not super familiar with the Lambda side. Certainly on the Google Cloud Functions side, there is ways of actually locking it down so that only particular event types. The way we've currently exposed this declarative eventing on Google is through Firebase Cloud Functions, actually, where we hook up functions that way, and then and that's all done within the Google world. Now. When you have events that are coming from outside the span of cloud of your one particular provider, that's when you start. But we don't currently have too many examples of that. So I would say this is more of a future threat. Okay, thank you.